Okay, you're right. For the rest of exercise 3B, we're just, again, finding the perimeter. And it's perimeter this time, not circumference. Well, in some cases it'll be circumference, but in questions 10, 11, and 12, it's actually perimeter. So let's have a go at some of these. I'm not going to do them all because I think you need to do them, but I'm just going to start the first one for you. So question 8, and it says, a water tank has a diameter of 3.5. Find the circumference. So it has a diameter of 3.5. So it's just that. And you can do that because if you did question 5, you'll be okay. It's just going to be pi times 3.5. Question 9. Athletics. An athlete trains on a circular track. Okay, so again, we've got a circle. And the radius is 40. So this is question 9. The radius is 40. And he runs 10 laps each day for 5 weeks. How far does he jog? Okay, well, let's work out what 1 lap. Well, that equals pi times d. Now, we don't have the diameter, we have the radius is 40. So the diameter is 2 times 40, which is 80. So 1 lap is pi times 80. But this athlete jogs 10 laps each day. So the total distance, because I'm going to do it all in one go, 10 laps. So 10 times pi times 80. And he does that for 5 days a week. So he times it by 5. And then it's just calculator work. So 10 times pi. Remember, you need to be able to find pi on your calculator, and it's shift and that button, the button below the 3, times 80 times 5. And what is that? 12566.3. 12556.3. And there are a whole lot of other numbers behind that. And we need to round to the nearest meter. So we'll put our line there. We look 1255. We look at the number behind that red line. Is it 5 or more? No. So we don't round. We leave it alone. We have rounded. We've rounded it to the nearest meter, but we don't change the number. Okay, so worded problems. You should be okay with those. Calculating the perimeter of these. I'm going to do C in 10, 11, and 12. All right, you see if you can do them. 10, 11, and 12. So here's question 10. It's a semicircle. So my perimeter is this bit, the curved bit, plus this bit. So the perimeter equals a half the semicircle, a half the circle, sorry. So half pi times d plus that straight bit, so plus the diameter. So it's a half times pi. And what's the diameter? They don't give it to us. They give us the radius again. So if the radius is 12, the diameter equals 2 times 12 is 24. So it's pi times 24 plus 24. This is the curved bit. That's the area of the curved bit, or the distance of the curved bit, and that's the distance of the straight bit. Then I just go to my calculator. A half times pi times 24 plus 24. 60, and what are we going to? Let's assume 2 decimal places. What is it? Yeah, 2 decimal places. So 61 point, what was it? 699, 699, and there are a whole lot of other numbers. Again, draw your red line, or whatever colour you use. It's going to be 61 point. Now, I've stopped a bit short here because this is an unusual one. I already know this is more than 5 or more. So I'm going to have to round that 9 up. But if I round that 9 up, it's going to go to 10. So I'm going to get a 0 there. And you must have it. You can't leave that 0 out. And because that's now 10, I have to add that 1 in the 10th in that column to there. So it becomes 61.70 millimeters. So because this number here is 5 or more, you round this up by 1, and that takes that to 0.70. Okay, so that was 10C. 11C. Whenever you get a part of a circle, you can always work out how much of a fraction it is. So, for example, if I had a sector and it was 60 degrees, well, how much is this bit of a circle? Well, there are 360 degrees in a circle, and I've only got 60 of it. And if I put that in my calculator, 60 divided by 360, and I get a sixth. That's a sixth of a circle. So when I'm doing 11C, all right, this bit is 45 degrees over 360 of a circle. But I've also got to remember I need to add these two straight bits as well to get the perimeter. So the perimeter for 11C, the green bit, which was a curved bit, is 45 degrees of 360, because that's how much of a circle it is, times pi times d. Oh, well, what's the diameter? Well, this distance is 2. Well, the radius is 2. So the diameter is 2 times 2 is 4. So 45 on 360 times pi times 4. Plus I've got to add the red bit. The red bit is just, and there were 2 of them, remember? There were 2 radii. Well, they were 2 and 2. Now again, I put all that in my calculator in one go, but I must show my working here in my substitution. So what have I got? 45 on 360 times pi, shift this button here, times 4, the diameter, plus 2, one of the radii, plus the other radii, 5.57. 5.570. There are a whole lot of other numbers there. Red line there is 5.5. The number behind the red line is not more than 5, so I'll leave that alone. What units was it in? Centimetres. Now, these ones, they look difficult. In question 12, they look difficult, but just add up the curved bits and add up the straight bits. 12A, when you work out how easy it is, yes. But let's have a look at C. What have I got? Well, I've got that straight bit and that straight bit. So that's 10 plus 10. And then I've got this part of a circle and this part of a circle. Oh, I've got a whole circle. This one is quite easy, 12C. The perimeter equals the two straight bits plus the circle. Well, the two straight bits are 10 plus 10, and the circle is pi times d. And what's the diameter? It's 5. And again, straight into the calculator. 10 plus, remember it's perimeter, plus 10 plus pi times 5. And I'll just check the answers because I've got them here beside me. What do we get? 35, yes. So 35.707, 35.707, a whole lot of other numbers, but again, you have to round to 2 decimal places. You should be getting good at that now. 35.7, the number behind the red line is 5 or more, so we round up and it was in metres. All right, you should have a go at those other ones. Good luck with those. And then there's a very hard question in 15. Well, hopefully you'll be able to do it.